Hey everyone, welcome to another interesting video on this channel on the topic of mathematics. This time we discuss in this video the Gaussian elimination versus the Gauss-Jordan elimination methods, right? So this is a very popular way in linear algebra matrices where we reduce the numerical count of a matrix to a lesser count that enables us to solve equations in an easier way as compared to what would have been if we would not have done this, right? To get a better awareness of what's being discussed in this video, I would recommend watching one of my previous videos on the topic called echelon forms of a matrix, right? The echelon forms of a matrix are the ones which actually are obtained using either Gaussian elimination or Gauss-Jordan elimination. So if we have a look at this on the whiteboard, right? The echelon form of a matrix is divided into two types, right? The first one is a row echelon form. The second one is a reduced row echelon form, right? So what's the difference between these two fundamentally? And row echelon form is the one where if you have like all 0 rows in a matrix, right? Let's say like 3, 2, 1, 0, 0, 2, 0, 1, and then 0, 0, 0, 0. So the first condition is that these all 0 rows have to be at the bottom, right? And the second condition is that the first non-zero row in the first non-zero value in every row is called as a pivot value. Like in the second row, this is the pivot value. This one has no pivot values. But then the second prerequisite is that these pivot values from subsequent rows have to be at the right side of each other. Like say, for example, in the first row, this pivot value, this is a pivot value, and then in the second row, in the next row, this is a pivot value. And as you see, this is at the right side of this value. So both these conditions are satisfied. So this is a matrix in the row echelon form, right? And reduced row echelon form is a slight modification of row echelon form where all the pivot values are supposed to be one, only one. And the second prerequisite is that all other values in the column, which is a pivot, which has the pivot value, all other values have to be 0. So here in the first column, you see this is, I mean, this is not a 1, but then all others are 0. But then over here, you see, this one is a 2 and this one is 0. So this cannot be reduced to echelon form. But then if you look at this matrix, right, like 1, 0, 0, 0, 0, 0, 1, 0, and then 0, 0, 0, 1. So here you see that these are pivots which are at the right side of each other, right? This is at the right side of this is the right side of this. And then all the other values in the pivot column are 0, right? So this is a reduced row echelon form of a matrix, right? So this directly enables you, so like suppose this X, Y, Z, and then this is like say something, something, right? So this directly enables you like Z equals something to get the values of the variables up front. That's the advantage of a reduced row echelon form, right? So what's essentially the difference between your Gaussian elimination and the Gauss-Jordan elimination? So both of these use like your elementary row transformations, right? Like if you recall from one of my previous videos on matrix transformations, you say row 2 gives rise to row 2 transforms to row 2 minus 2 row 1, or like say row 3 transforms to half of row 3. So these are the transformations which you make on either side of a matrix, right? Like say, for example, you have a matrix that looks like this in the augmented form. right? Like 3, 2, 0, 0, 2, 1, 0, 0, minus 1, right? 2, 1, 3. So like suppose like you want to make this thing as 0, you add row 2 transforms to row 2 plus row 1. So this will be 0. And then this 1 becomes 1 plus 3, right? Which is equal to 4. So those are elementary row transformations. So like you make these transformations to either side of the matrix, and both Gaussian elimination and Gauss-Jordan elimination involve these transformations. But the only difference is that Gaussian elimination results in your matrix, like basically you stop when the matrix becomes a reduced echelon. When your matrix becomes a row echelon form, that's when it's called as a Gaussian elimination. And once you stop when your matrix becomes a reduced row echelon form, that's what it's called as a Gauss-Jordan elimination, right? That's essentially the technical difference between these two. Otherwise, both of them use the same elementary row and column transformations, right? That's a really short way to look at the fundamental differences between a Gaussian and a Gauss-Jordan elimination. I mean, there's nothing more to that. It's as simple as that, right? So I hope this video was useful to you, and you're now in a position to solve matrix equations using either Gauss elimination or Gauss-Jordan elimination, right? The only prerequisite is that there should be no redundant rows in a matrix, right? Like if you want to be having some uh, echelon form, or like say a reduced row echelon form, suppose 2, 4, and then 1, 2. So you see, this is like x plus 2y equals something, something, and this is 2x plus 4y equals something, something. So this row is nothing else, but it's just a repetition of the bottom row, right? So in this case, it's difficult to get, it is not possible to get the kind of form, the echelon forms that you want. So you have to just keep that in mind. Otherwise, the way to get the echelon forms is the same as the elementary row transformations, right? Whether it's Gaussian or Gauss-Jordan. So I hope this video was useful, and I'll come up with more such videos in the future based on your request. If you like this video, kindly comment at the bottom, or maybe like the video and then subscribe to the channel. Until then, I wish you all the very best with your preparation, and until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video, and see you in another video. Bye bye.